The most powerful place on Earth is tucked away inside of a network of underground tunnels that belong to the world's largest particle accelerator. It's called the Large Hadron Collider, and this machine takes some of the smallest particles known to man and collides them at speeds of 99.9999% the speed of light. To understand how the LHC works, you can break it down into three components that act like its body, brain, and heart. The body is the underground tunnels that form a giant circle that's 17 miles around. Physicists actually ride bikes to get to different parts of the machine. Inside these tunnels is an environment so empty, it's similar to what you'd find in the vacuum of outer space. And that's just the way physicists like it, because they need it to be completely empty so they know exactly what they're looking at when they start smashing particles together in the most energetic game of bumper cars imaginable. When the particles collide, the extreme energy produced in the event creates entirely new and different particles. And because these particles are too tiny to see with the naked eye, the LHC has 4 gigantic detectors, which are the brains of the outfit. Each detector weighs tens of millions of pounds, is comparable in size to the main hall in the Notre Dame Cathedral, and is by far the most complex structure of the LHC. These are what physicists use to sift through the messy leftovers after a collision to spot special new particles. But the detectors would have nothing to sift through if it weren't for the LHC's heart, which is the critical piece of technology that pumps the particles through the tunnels at such incredible speeds. The particles are moving so fast that they complete 11,000 laps around the 17-mile loop every second when the machine is running. The heart is a series of more than 1,000 super-chilled magnets that are colder than outer space itself, making the LHC the largest cryogenic system in the world. These magnets are chilled to -456 degrees Fahrenheit, because at these temperatures, physicists can generate strong electrical currents that power the particles through the LHC tunnel. Without these cold temperatures, there wouldn't be enough power to generate the types of high-energy collisions you need to disassemble particles into their smaller, more fundamental components. The most important part about the LHC is that it's uncovered an entirely new world, the realm of the extremely tiny. In this world, there are physical forces that are trillions upon trillions upon trillions of times more powerful than the force of gravity. And it's these forces that bind the quarks that form the protons and neutrons that make up the atoms of all the matter we see in the universe. Sometimes the best way to think big is to go small.